Hey, good morning, and I hope everything works okay here because I'm a couple of 3,000 miles away. Today is day 6. All right, today we're going to cover chapter 3, section 2, quadratic equations, functions, and zeros. All right, now, how do we know if something's a quadratic equation? Well, up until now, we've really discussed linear equations. And that have the form y equals mx plus b. We know that's a linear equation because of the exponent. This exponent is 1. We call that the degree. So that's a linear equation. Also, remember, when we talk about functions, the f of x is the function f of x is the same thing as y. All right. Now, what does the degree tell us? It tells us the shape of the function of the graph, and it tells us the number of possible solutions. Right? So that's what we're looking at with linear equations. Now, a quadratic equation is one that looks like this. Well, it's as an equation, it has 3 terms. We set them equals 0. Right? So that's linear equations have at most 2 terms. Quadratic equations have 3 terms. So that's the first thing. If you also notice, the degree is 1 less than the number of possible terms. There's 1 degree here, and we have 2 terms. A degree is 2 here, we have 3 terms. When we say quadratic function, what we're looking at here is f of x equals ax squared plus bx plus c. So whenever we talk about quadratic equations, we set them equal to 0, and whenever we talk about functions, we have equals f of x. The only thing has to be true about these is this is called the leading term. And A is called the leading coefficient. So whenever you get an equation, what you have to do is put them in decreasing order with the exponents. But x squared, x, no x. Right? So the leading coefficient cannot be 0, because if it's a 0, it becomes a linear equation. All right, so those are very important concepts. solving quadratic equations. From now on, I'm simply going to call them QE for quadratic equations. We actually have 4 methods of solving quadratic equations. One method is factoring. What factoring does, it takes an equation like ax plus a and breaks it down to its smallest pieces. That's factoring. The next method we call is the square root method. And that's when we use square root to solve both sides. The third method is the square method. And the last method is called the quadratic formula. All right, so those are our 4 methods of solving. And we're going to go through each one of them separately. But first, we have to look at a couple of principles. Principles of solving quadratic equations. First, we're going to talk about the square root. Principle. The square root principle says this. If I have anything squared equals something, I want to get rid of the square. When I square root both sides, I have to put a plus and minus in front of the answer, because the square and the square root cancel, leaving us y equals plus or minus whatever the square root of that number is. For example, we have if x squared equals 4, and if I square root both sides, I have to put plus or minus the square root of 4. So the square and the square root cancel. We have plus or minus 2. This thing tells me that x can equal positive 2 or x can equal negative 2. Negative 2 times negative 2 is 4. Positive 2 times positive 2 is 4. All right. And then the second one, the second principle is called the zero product principle. What the zero product principle tells us is if we have 2 terms multiplied together and they equal 0, so if we have this, then a equals 0, b equals 0, or a and b both equal 0. And we go ahead, and for this case, since we don't know which one's which, we always set them both equal 0 and then solve for x. All right, so let's start looking at different types of quadratic equations we have. because a quadratic equation can be a binomial or trinomial. In other words, it can be comprised of two terms or it can be comprised of three terms. So binomial looks like this. Binomial looks like this. 2x squared plus 4 equals 8. Because remember, it has to be equal to 0, so we have to subtract 8 from both sides, will give us negative 4 equals 0. We only have two terms, so it equals 0. A trinomial would look like this. Right, so let's look at binomials first. With only one term containing an x. There's two types. Either only one term has an x, or both terms have an x. So let's look at x squared minus 4 equals 0. So if you have only one term, here are the steps. Isolate the x term. So we have to get rid of the 4 on both sides. So we have x squared equals positive 4. Then square root both sides. So x is equal to plus or minus 2. All right. So those are our possible solutions. Always, 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 always check your answer. Oh, CYA. So does positive 2 fit in there? 2 squared is 4. 4 minus 4 is 0. So when x equals 2, we have 2 squared minus 4. So it's 4 minus 4 equals 0. So it's 0 equals 0. Check. Then when x equals negative 2, negative 2 squared equals 4. No, that's what I moved over. So does 4 equal 4? Yes. So that's the first one we're looking at with binomials with only one term having an x. But these are still quadratic because they have an x squared. So if it only has one term containing x, we use the square root method. And in the second, both terms have an x. Then we use the factoring method. right? Let's see how this one will work. Let's say we had 2x squared plus 4x equals 0. Now we only have two terms, set equals 0. Check. Well, that's what I should do. So we have to first make sure our equations equal 0. So set it equal to 0 first, then we see what it looks like. Since you have two terms, only one of them have x. That's, this one has both x's. So what do we do here? Since they both have what in common? They both have a 2 in common. So this one looks like this, 2x times x. That's what that one looks like. This one, 4 is made up of 2 times 2 times x. So what do they both have in common? They both have a 2 and an x, a 2 and an x. So I can factor out the 2x. Now, whatever is left after I take out the 2 and the x goes inside the parentheses. So remember, whenever you factor something out, it's like dividing. If I divide both of these by 2x, what do I have left? The 2's cancel x, so I have x plus the 2 and the x cancel, so we have 2. So this equation is the same as that one. It's just that we have no more exponents. So what we do now, since we have two terms, we set them both equal to 0. Anywhere you see an x, set that equal to 0. So 2 times x equals 0. So I divide by 2. X equals 0. That's one solution. And then this one, I subtract 2. So x equals -2. Here's another possible solution. So let's check them both. Remember, always check your answer. So say with x equals 0. 2 times 0 squared plus 4 times 0. 0 squared is 0. 2 times 0 is 0. 4 times 0 is 0. So check it works. So 0 is a solution. Then x equals -2. I have 2 times -2 squared plus 4 times -2. So order of operations, I do the parentheses first, exponent, -2 squared. So -2 times -2 is +4. Next one is positive times negative is negative. 4 times 2. So 2 times 4 is 8 minus 8 equals 0. So they're both equals, those are both solutions. So we use, depending on if it has two terms and it's a quadratic equation, we can either use the factoring method or we can use the square root of 0, depending on what the function looks like. Now, let's look at three terms. They're trinomials. So now, if it has three terms, the function will look like this. Now, this means there are two possibilities. A equals 1 or A does not equal 1. And of course, remember, A can never equal 0. Okay, so if the leading term is 1, we have a certain method to do it. And if the leading term is 2. Right. Either way here, we have to use factoring because we have 3 terms. We can't use the square root method. Not just yet. Right. So before we start doing some actual problems in there, let's look at some examples of what this stuff looks like. I'm gonna give you some examples, but we want to break down these steps. So let's work these out first. We'll multiply these together. X plus 2, x minus 3, x minus 2, x plus 3, and then x minus 2, x minus 3. These are the only possibilities that can occur when we factor a trinomial, we'll get 2 binomials. And these are the only possibilities that can occur when we factor those. They'll both be pluses, plus minus, minus plus, or both minuses. All right, so let's look at these. If we multiply these together, so x times x is x squared. Then x times positive 3 is positive 3x, positive 2x, and positive 6. Combine like terms, we get x squared plus 5x plus 6. There. Let's do the same thing with the next one. X times x is x squared. Positive times negative is negative. X times 3 is 3x. Positive is positive. 2 times x is 2x. Positive times negative is negative. 2 times 3 is 6. Combine like terms. Negative 3 plus 2 is negative x minus 6. Next one, x times x is x squared plus 3x minus 2x minus 6. So we get x squared. Positive 3 minus 2 is a positive 1x. And then the last one, x times x is x squared minus 3x minus 2x. Negative times negative is a positive. 2 times 3 is 6. So we get x squared minus 5x plus 6. All right, so what we're looking at here now are the 4 possible ways that these terms can be given to us. What we're trying to do going this way, factoring is taking the equation and breaking it down to the smallest pieces. All right, so let's see how it's done. Here are the steps. Factoring steps. First off, set the equation equal to 0. So let's look at the first one. We're going to do the first one. We're going to do each one of those and look at what happens. So we set the equation equal to 0. A is 1. Check. since we're going to factor, put down our two sets of parentheses. Why do we know it's going to have two sets? Because this tells us we have two answers. So we have to break it down to two equations. Since A is 1, place x's in the first spots. So we have x and x. That takes care of our first term. X times x is our first term. Look at the second sign. The second sign is going to tell us what signs go inside here. If it's a plus, both signs are the same. And they're the first sign. So since that's a plus, we know the only way that could be a plus is if this number times this number have the same sign. They both have, in this case, they both have pluses. If it's a minus, then the signs are opposite. One's a plus and one's a minus. Now we look at the third term. Find two terms, or two numbers, that when multiplied equals your third term. And then when you second sign them, you get the middle term. You get the second term. Well, I'll do it here. So here, for the numbers, we look at the third term. Let's find what two numbers multiply to give you that third term, that when you add or subtract them, you get the second term. So what two numbers multiply to give us 6? That, since this is plus, that when we add them, we get 5. Yeah. 3 times 2, 3 plus 2. And since they're both the same signs, we just put them both in there. And there we have it. That's how we factor them out. And sure enough, this one came from x plus 2, x plus 3. It doesn't matter which way you write them. 3 times 4 is same thing as 4 times 3. Now the last step is solve. Set both terms, or the parentheses, equal to 0 and solve. So we set both of these terms, x plus 3 equals 0, and x plus 2 equals 0. So x equals -3, x equals -2. Those are my solutions. And we always remember, check your answers. If x equals -3, we have -3 squared plus 5 times -3 plus 6. Does that equal 0? -3 squared. -3 times -3 is 9. Positive and negative is negative. 5 times 3 is 15. 9 plus 6 is 15. Minus 15 is 0. So check. And the same thing with -2. So when you check your answer, make sure you do both of them. All right, so that's the first one. That's the first one here. Let's look at the second one. Let's look at the x squared minus x minus 6. Set that equal to 0. Leading term is 1. Check. Put my 2 parentheses down. Equals 0. Look at what makes up x squared, x and x. Next step, look at the second sign. Since it's a minus, that means they're both opposite signs. But I forgot to say over here, if it's a minus, signs are opposite. One's plus, one's minus. Here, in your solutions, the larger number gets the first sign. So we know the signs are opposite, plus or minus. Since this is a minus, the bigger number will go there. All right, so now we have to find what two numbers multiply to give you 6. Since that's a minus inside there, when I subtract them, it equals 1, the B term. So 3 times 2 is 6. 3 minus 2 is 1. Since the first term is a negative, the bigger number gets the 3. Gets negative. And so we can see this one, it came from x plus 2, x minus 3. So there's the check. Set them both equal to 0. And solve. We got x equals -2, x equals 3. And then check your answer. But they'll both work. The third one, we have x squared plus x minus 6. This one is similar to the one we just did. The first, it's x squared, so it's x times x. Second sign's a minus, so they're opposite signs. The first sign's a plus, so the bigger number gets the plus. Find out what times what equals your last term, which is 6 in this case. That when you subtract them, you get 1. Same as the last one, 3, 2. But since the first sign is positive, the bigger number gets the positive. We get our solutions by these two. x minus 3, x plus 2. Again, you can plug them in there and check your answers. And the last example, x squared minus 5x plus 6 equals 0. We have to make sure it equals 0. The leading term is 1. So now I can factor. What makes up x squared? X times x. The second sign is positive, which means they're both the same sign. They're both negatives. What times what equals the last term, 6 in this case, that when I add them, I get 5. So 3 times 2, 3 plus 2. And since they're both the same sign, it doesn't matter who goes where. Set them both equal to 0 and solve. And check your answer. Right, so that's the procedure of factoring. So let's look at some examples. What if we had x squared minus 3x minus 4? That equals 0. Okay, first step, set it equals 0, check. Second, is a equal 1? Yes. So I can go ahead and put my parentheses down. X and x go in the first one. That makes up x squared. Second sign is a minus, so opposite signs. The bigger number is the negative. So what times what equals our last term, that when I subtract them, I get my middle term. 4 times 1, 4 minus 1. And the bigger number gets the minus. So the 4 goes here, the 1 goes here. And if you want to, you can go ahead and multiply these together, see if you end up with that. That's a check method for this. Set both of these equal to 0 and solve for x. X equals -1 and x equals 4, which we knew that from chapter 1. Whatever's inside the parentheses is always the opposite. And check your answers. Now, what do these represent? Those are where the graph is going to cross the x-axis. So solution is the same thing as the x-intercept. So our graph will look something like this. Because it is a parabola, it's x squared. It tells us we have 2 solutions possible. It looks like this. Let's look at another one. X squared plus 6x plus 9 equals 0. Equals 0, check. A is 1. Put my parentheses. So I have x and x. Second sign's a plus, so they're the same sign. They're both going to be pluses. What times what equals 9? That when I add them, I get 6. 3 and 3. And we'll see that both of these solutions will give us x equals -3. So what that graph looks like, so 1, 2, 3, so at -3, we have only one x-intercept. So that looks like this. All right, so if you have the same answer, that means it only touches one time. And this is going to be important when we get to this next part. Let's do another example. What if I gave you this? If I gave you this equation, what first thing we notice, okay, we set the equation so it's highest exponent down to the lowest exponent. Check, ordering it. Now, can you factor anything? Always look, can you simplify the equation before you start? Now, in this case, all of these have one x in common. So I take out one x. If I take out one x, I get this equation. Even though this wasn't quadratic when we first began, we could make it into quadratic because we can factor something out. So now we can go ahead and factor this quadratic one. So x and x being term. Second term's a plus, so the same thing, same signs. They're both pluses because the first sign's a plus. What times what equals 6? That when we add them, we get the middle term, 5. 3 times 2, 3 plus 2. And since they're both the same signs, it doesn't matter. All right, now, what this is telling us, we have to, anywhere you see an x, set that equal to 0 when we solve for them. We know we're supposed to have 3 solutions because the degree is 3. So x equals 0 is one of them. X equals -3 is another one. And x equals -2 is the third one. So that's what we're looking at here. Right. So those were trinomials with a leading coefficient of 1, the leading coefficient of 1. What if a does not equal 1? A does not equal 1, that opens a whole can of worms. Because now the procedure changes. and it becomes a little bit more complex because now we have more steps to involve. For example, what if I had 2x squared minus 5x minus 3 equals 0? Okay, the first thing I'm going to check, can we factor anything out? So basically, we're looking for, hopefully, all these terms were factors of 2. So we can take out the 2 and make the leading coefficient 1. So since that doesn't happen, we now have to follow these steps. Well, the first steps are pretty much the same. Set it equal to 0. In this case, okay, we know that the leading term a is not equal to 1. So what I do here, I just copy down the first term with the leading coefficient. So x times x equals x squared, and the 2 is the first one. We'll fix that at the end. All right, so that's the first one. Set equal to 0. Put ax into both of them, whatever the a is. The second sign test, since it's a minus, we know they have to be opposites. Since the first one's negative, the bigger number has to be the negative. Now, here's where it's different. Remember, a quadratic equation has this form. So the fourth step is multiply the a times the c. A in this case is 2. So let's label these things. A is 2, B is -5, and C is -3. So we multiply A times C. We have A times C equals 2 times 3. We don't need the signs because, I mean, we know what they have to be already. So just the numbers. 2 times 3 is 6. Now we got to find what two numbers multiply to equal that A times C. That when we second sign them, we get the middle term. So A times C is 6. So we figure out what two numbers multiply to equal 6. That when that's a minus, I subtract them, I equal 5. Six times 1, 6 minus 1. Put the numbers inside the parentheses. So the numbers are 6 and 1. Again, since the second sign was a minus, signs are opposite, the bigger number gets a negative. So the 6 goes here and the 1 goes there. Factor, if possible. So we have right here. Can anything factor out of this first parenthesis? No. So it's 2x plus 1. Can anything factor out of the second? Yeah. They both have a 2 in common. Because this is 2x, this is 2 times 3. I can factor out a 2. So what goes inside the parentheses divide both of these. So the 2's cancel, so we have an x, minus the 2's cancel, so we have a 3. Remove that factor. So to erase that one, these are your answers. I'm not the answers, but you'll get to the answer. So I set both of these equal to 0, and I solve. Subtract 1 and divide by 2. And then move the 3 over. And those are both my solutions. So far, so good. All right, hold it. Now I have to clear up some more space on my papers. So hold on, everybody. All right, so let's look if we had this example. We had 6x squared minus x minus 2 equals 0. Nothing factors out of all three of them. It's set equal to 0. Check, check. So let's create the factor. A x, A x. Look at the second sign. It's a negative, so they're opposite signs. The bigger number will have that sign. So now we're going to find A times C, which is 6 times 2 equals 12. What two numbers multiply to equal 12? That when since it's the second sign's a minus, since we subtract them, it equals 1. So the only ones I can think about are 4 and 3. 4 minus 3. So the bigger number goes inside where the minus is because the first sign's a minus. And the second one's a 3. Now, can we factor anything out of this first one? Yeah, they both have a 3 in common. Okay, if I divide both of these by 3, since I factored it out, 6 divided by 3 is 2x. 3 divided by 3 is 1. Same thing there. Can't factor. Do they have anything in common? Yes, they both have a 2 in common. So if we divide both of these by 2, 6 divided by 2 is 3x, minus 4 divided by 2 is 2. Erase what I factored out. And now these are my factored forms. Set them equal to 0. Subtract 1. So we have 2x equals -1. Divide by 2. So x equals -1/2. There's our first solution. The second one, we add 2. 3x equals 2. divided by 3, x equals 2/3. Those are my solutions, and of course, plug them in there and check your answers. It's pretty much straightforward. That point is, and these are the hardest part, our hardest type of questions you can do, because the leading term can have multiple factoring possibilities. Like what can equal 6? We could have 1 and 6, 6 and 1, 2 and 3, or 3 and 2. And the position is important because since the signs are different, it's going to give us a positive or negative answer. All right, so that's the factoring and the square root methods we talked about. Now the third method, the complete the square. Complete the square method. This is an entire process. We're given an equation, quadratic equation. So it's set equal to 0. Let's look at example 3 for this one. So we have f of x equals x squared minus 6x minus 10. We know we can't factor this one out. We know because, okay, what times what is 10? When you subtract them, you get 6. It's either 10 times 1 or 2 times 5, and neither of them subtract to give you 6. So we can't factor this one. So here are our steps. So again, it has to be set equal, it has to be an equation, it has to be set equal to 0. First step, a has to equal 1. If it doesn't, divide each term by a. So that's very important. The leading term has to be 1 for this method to work. So we have here, we have x squared minus 6x minus 10, set it equal to 0. Leading term is 1. Move the c term to other side. So move the constant term over there. So it's x squared minus 6x equals 10. Whenever you move a number to the other side, always change the sign. So we add 10 to both sides. Now here's where we start the process of complete the square. Add b over 2 squared to both sides. Add b over 2 squared to both sides. So remember, b is whatever's in front of the x. In this case, it's just 6. Not the sign, just the number. So we have x squared minus 6x plus 6 divided by 2 squared. 10 plus 6 divided by 2 squared. To the left side, only do inside the parentheses. So we have x squared minus 6x plus 3 squared. the right side, work it out. So we have 10 plus 6 divided by 2 is 3 squared. 10 plus 3 squared is 9. So 10 plus 9 is 19. Right, so now we're going to do, we set it all up. Now we're going to do the actual complete the square part. So we have x squared minus 6x. Do we have minus 3 or plus 3? Plus 3 squared equals 19. Complete the square. So on the left side, this is A. The left side, put parentheses and a square equals the number. So on this side, we're going to have a big parentheses squared. Now, inside the parentheses, put first term. This is whatever's under the squares. So whatever's under the squares, so the first term is x. The first sign, whatever the first sign is, it goes in there. And then the third term. So whatever's under the square, it goes inside there. That's complete the square. Because from this point, we can do one of two things. We can either solve for x, which will give us the x-intercepts, or we can move it over and it'll help us graph it. But since we're looking for the x-intercepts, we want to solve. In other words, we're trying to get to x. This is step 7. Square root both sides. So we have square root of x minus 3 squared equals the square root of 19 plus or minus. We cannot forget the plus or minus part. So the square root and the square cancel. So we have x minus 3 equals plus or minus the square root of 19. And solve for x. Add 3 to both sides. So x is equal to 3 plus or minus the square root of 19. Those are our two solutions. We have x equals 3 plus square root of 19. X equals 3 minus the square root of 19. That's complete the square. Let's look at another example. X squared plus 5x plus 6 equals 0. Again, notice how we're doing these with the leading coefficient being 1. We'll increase it to another number in a second, and we'll have fractions in a second too. So it's set equals 0, a is 1, so move the c term to the other side. So we have x squared plus 5x equals -6. Add b over 2 to both sides, x squared plus 5x plus 5 over 2 squared equals -6 plus 5 over 2 squared. The left side, only do inside there if you can. Can't do anything, so it's done for right now. But on the right-hand side, we have to work it out. We don't have a choice. So we get -6, 5 over 2 squared. So we square top. So 5 times 5 is 25. 2 times 2 is 4. We need to have a common denominator. So we have -6 over 1 plus 25 over 4. The common denominator is 4. So I got to multiply this one by 4 over 4. So -6 times 4 is -24 plus 25 over 4, which makes it 1 over 4. Not difficult, just a lot of steps. All right, so we solved the right-hand side and fixed. So now we're ready to complete the square. Whatever's under the square, so it's x, the first sign, and the 5 over 2 equals 1/4. To solve, I square root both sides. So I get, so those and those cancel. So I have x plus 5 over 2 equals plus or minus the square root of 1/4. Well, the square root of 1/4, I can split those up. Square root of 1 over square root of 4. Square root of 1 is 1, square root of 4 is 2, equals plus minus 1/2. Solve for x, subtract 5 over 2 from both sides. So x equals -5 over 2 plus or minus 1/2. Our two solutions. -5 over 2 plus 1 over 2. -5 over 2, because of that, minus 1 over 2. -5 plus 1 is -4. Over 2 is -2. In the bottom here. -5 minus 1 is -6. Equals -3. And check your answers, and we'll see those are the right answers. That's what we did previously. All right, now let's look at one where a is not equal to 1. Example 4. What if we had 2x squared minus 1 equals 3x? All right, first off, there's a couple things wrong here. It doesn't equal 0, so my first step, move the x to the left side. So it's minus 3x minus 1 equals 0. That's first one. Set equals 0. Now, is the leading term 1? No. So divide by 2. I divide each term by 2. So that gives me x squared minus 3 over 2x minus 1/2 equals 0. All right, we have leading term is 1. So move this one to the other side. Move the constant term to the other side. So I add 1/2 to both sides. Add, here's the b term. So I had 3 over 3/2 over 2 squared to both sides. So whatever that b term is, 3 over 2 divided by 2 squared. Right, so let's look what happens here. We have a fraction over 2, which is 2 over 1. So we have a fraction over a fraction. Take the top fraction, leave it alone, and multiply it by the flip of the bottom. So 3 times 1 is 3, 2 times 2 is 4. So it's 3 over 4 squared. 1/2 plus 3 over 4 squared. The left-hand side, whatever's under the squares, whatever the first sign is, that goes in the parenthesis. Now the right-hand side has to get worked out. So it's 1/2. 3 squared is 9. 4 squared is 16. So I have to get a common denominator, which is going to be 16. So this one, what times 2 is 16? 8. Top and bottom. So we have 8 plus 9 makes it 17 over 16. We're trying to get to x, so we square root both sides. So the square root and the square cancels. We have x minus 3/4 equals plus minus square root of 17 over square root of 16, which becomes square root of 17 over 4. So we have x minus 3/4 equals plus or minus square root of 17 over 4. Add that to both sides. So x equals positive 3/4 plus or minus square root of 17 over 4. Those are my two answers. X equals 3 plus square root of 17 over 4. Since they have a common denominator. That's one of them. And then the other one is x equals 3 minus square root of 17 over 4. And check your answers. So there's if you have a fraction in your equation. All right. Now, that's the most grueling part, but it's necessary because it'll help us to solve various parts of our function. Now comes the easiest part, the easiest method, the quadratic formula. This one is simply plug and play. Let's see how it works. So we have a quadratic equation. Set equals 0. Here are your steps. Set equals 0. And it doesn't matter what A is. There's nothing, no condition other than set equals 0. Label A, B, and C. Tell me what they are. Plug into but the quadratic formula is this one. Negative B plus or minus the square root of B squared minus 4AC over 2A. Just plug in your ABCs in there and solve. Let's do an easy one first. X squared plus 5x plus 6 equals 0. Yeah, we could go ahead and factor that one. We know it's going to be x plus 3, x plus 2, which is x minus 2, x minus 3 is solutions. But let's use this method. First off, label A, label B, and label C. Since it equals 0 already, A is the coefficient of x squared. B is the coefficient of x, and C is the constant. If it's a negative, make it a -5. If it's a negative, make it a -1. So the signs are important here. So we have negative B plus or minus square root of B squared 4AC over 2A. That's the formula. So negative, what is B? B is 5. If B was -5, I'd put parentheses -5 inside there. Plus or minus 5 squared minus 4 times 1 times 6. That's 4AC over 2 times 1, 2A. We have -5 plus or minus the square root. 5 squared is 25 minus 6. 4 times 1 is 4 times 6 is 24 over 2 times 1 is 2. So -5 plus or minus 25 minus 24 is 1. So -5 plus some square root of 1 is 1. So we have -5 plus 1 over 2 and -5 minus 1 over 2. Because we have to take 1 for each of these. This is for plus, and this is for the minus. -5 plus 1 is -4. -4 divided by 2 is -2. -5 minus 1 is -6 over 2 is -3. And it's the same solutions we had last time. Okay, so let's look at a more complex one with an a that doesn't equal 1. Example 6. What if we had 3x squared plus 2x equals 7? So first step has to be equal to 0. So subtract 7 from both sides. Second step, label A, B, and C. A is 3, B is 2, C is negative 7. Step 3, plug it all inside our equation. Negative b plus or minus the square root of b squared minus 4ac over 2a. So b is 2, so it's negative 2 plus or minus 2 squared, 4 times 3 times negative 7 over 2 times 3. Just plug and play. Negative 2 plus or minus 2 squared is 4. Negative times negative is positive. 4 times 3 is 12. 12 times 7 is 84 over 6. So it's negative 2 plus or minus 84 plus 4 is 88 over 6. All right, so can we simplify inside the radical? So what is 88 made up of? 8 times 11. 8 is made up of 2 times 4, and that's 2 times 2. So here's, since it's inside the square root, there's a pair of 2's. They come out as a 2. And inside there is a 2 times 11, which is 22. All right. So now since they both have a 2 on top, I can factor out a 2, which makes it negative 1 plus or minus square root of 22 over 6. The 2 and the 6 now can cancel. So I have negative 1 plus or minus square root of 22 over 3. Those are my 2 solutions. Go too deep in this. So the beautiful thing about the quadratic formula is you can determine the actual number of real solutions. Remember, in quadratic equations, we have one of three possibilities. It can look like this, where you have two solutions. It can look like one, like this, one solution. Or like this, we have no real solutions. In other words, you'd have an imaginary answer. And here's a note. If you have an imaginary answer, it always happens in pairs. So it always happens in two parts. Remember we did the conjugates? So if you have an I, you also have to have a negative I. Let's see how the way we do this is by using the discriminant. The discriminant, remember in the quadratic formula, only thing inside this equation that tells us how many solutions we're going to have is this right here. That's the discriminant. B squared minus 4ac. Because think about it. If b squared minus 4ac is positive, then we get two real solutions. That's that one. Because think about it, if it's positive, say it's a 4. So we have a square root of 4 is 2. We have whatever this is, plus or minus 2. So there's our two solutions. If our discriminant is equal to 0, then we only get one real solution. That's this one. If this is equal to 0, it disappears. All we have left is negative b over 2a. And that will become important to us in the next section. And then lastly, if the discriminant is less than 0, then no real solutions. Because if that's negative, then we have an imaginary term. Right? And once it's imaginary, there's no way we can graph it. Right, so before we start anything, we can say exactly how many solutions we're supposed to have. What if I gave you this equation? Is that quadratic? Well, clearly no, it's a 4. And the quadratic has to have a power of 2. But it is quadratic in form. In other words, we can have u squared plus bu plus c equals 0. Because if the exponent of the middle term times 2 equals the exponent of the first term then it is quadratic in form. So if we look at here's the power of the middle term is 2. If we multiply by 2, we get the first term. So it's quadratic. Why is that important? Is because now since it's quadratic in form, we can still use what we've talked about in the past to solve it. So let's see if we can factor this one. This is important as well. Remember, okay, and we did the quadratic formula. Remember, quadratic equations are ax squared plus bx plus c. We always solve for that middle variable. That's why it's an x. That's what we're solving for. How does that relate to here? We're solving for x squared. So here, our terms will be x squared. Second sign is a positive, tells the same signs. In this case, they're both minuses. What times what equals 4? That when we add them, we get 5. 4 times 1. Now we take both of these and solve. Remember, we're supposed to have 4 answers because the degree is 4. And this is where we're going to get them. Because here, if we solve for this, we have x squared equals 4 and square root both sides. So x equals plus or minus 2. Move the 1 over there. So x squared equals 1. Square root both sides. So x equals plus or minus square root of 1 is 1. Those are my 4 solutions. So x equals negative 1 and 1, negative 2 and 2. Those are our 4 solutions. Will it always be that straightforward? Usually not. Because what's going to happen here is we can have, whoops, we can have rational exponents. And we can have equations that look like this. Is that quadratic in form? Well, let's see. If I take the middle term, 1/3, times 2, I get 2 times 1 is 2. Do I get the first term? Yes. So it is quadratic in form. So I can use any method I want to. But what I'm solving for is this term. So it's x to the power 1/3, x to the power 1/3. It's a negative, so the signs are opposite. And the bigger number will be negative. What times what equals 3, that when I subtract them, I get 2. 3 times 1, 3 minus 1. So 3 goes here, and the 1 goes there. All right, so take both of these, x to the power 1/3 plus 1, set them equal to 0. X to the power 1/3 minus 3 equals 0. Subtract 1 from the first one, add 3 to the second one. So we have x to the power 1/3 equals -1. X to the power 1/3 equals 3. Now this right side is going to be a true answer. What about the left side, the left one? Can this number equal a -1? Yes, because it's a power of 1/3. It's an odd function. If it was 1/4 or 1/8, then it could not equal negative. It'd be imaginary. So the question is, how do we get rid of the exponent of 1/3? We want the power to be 1. So what times 1/3 gives us 1? 3. So we raise both sides to the power 3. So the exponents cancel. We get 1. -1 cubed is -1 times -1 times -1 is -1. So there's our first answer. Those cancel. So we have 3 times 3 is 9 times 3 is 27. And there's our second answer. All right. So, I mean, it's not difficult, but it does take practice. And again, we could have used the quadratic formula in this one. We had this equation here. We had x to the power 2/3 minus 2x to the power 1/3. First decide, is it quadratic in form? Yeah, because this exponent times 2 gives us that exponent. So it's quadratic. So I label my A, B, C. A is 1, B is -2, C is -3. Remember, whenever you solve for anything, you solve for no. So this one becomes x to the power 1/3. That's what we're solving for here. So we have -b plus or minus b squared minus 4ac over 2a. So it's negative of a -2, -2 squared minus 4 times 1 times -3 all over 2 times 1. I just plug in A, B, and C where they belong. So negative and negative makes it a positive. -2 squared is 4. Negative and then negative is positive. 4 times 3 is 12 over 2. We have 2. 4 plus 12 is 16 over 2. Square root of 16 is 4. We're just doing order of operations. So our answers can become, this is our first answer, which is 2 plus 4 over 2 is 3. And our second answer, we have 2 minus 4 over 2. So it's negative 2 over 2 is negative 1. And those are the solutions. All right, well, that does it for that section. We'll pick up next week. And actually, we're going to start picking up on some of these topics are going to be super straightforward. But since these are whole new concepts, I want to just slow down, take it step by step by step. And then now we'll start throwing things together. And we'll pick up the pace until we get to the middle of chapter 4. All right, then I'll see everyone. Any questions? No. If not, then I will